We're going to talk about 2D vectors now. So this is again starting off into 2D kinematics. So let's figure out how we're going to add vectors in 2 dimensions. So now we have a plane that is flying perpendicular to the wind. So whenever they're no longer in the same plane, we cannot add or subtract. And this was that extension question in the distance versus displacement problem that you had in that very first packet of 1D. All right, so in this example, we have the plane's velocity is 400 meters per second west. So we'll go ahead and draw that. So 400 meters per second to the west. And now the wind is going to go 200 meters per second north. So 200 meters per second north. And again, this whole head-to-tail method, if you watch the 1D, it talked about head-to-tail method. You always put the tail of the next vector at the head of the one before it. So our first vector was the 400. At the head of the 400 vector, we put the tail of the 200 vector. So this gives us our resultant, which is from start to finish of this line, going to the northwest. And this is what we're trying to find. So now you probably notice that this is a right triangle. So how do you solve for the longest side of a right triangle? Well, this is called the hypotenuse. And we use Pythagorean theorem. A squared plus b squared equals c squared. And so it doesn't matter which one's a. Let's do the first one that we did. So 400 squared plus 200 squared equals c squared. 400 squared is 160,000. So you literally just do 400 squared. And then 200 squared is 40,000. That equals c squared. And this gives us 200,000 equals c squared. So now how do we get c by itself? You have to square root both sides. This gets rid of your square on this side, and when we take the square root of 200,000, we get a c value of 447.2 meters per second. So for WebAssign purposes, while you're working through this, do not overround. You want to use at least 4 or 5 digits as you're going through here if you decide to round. But your final answer needs at least 3 non-zero numbers. All right, let's do another one. So here we have a baseball is thrown with an upward velocity of 5 meters per second and a forward velocity of 7 meters per second. And we're looking for the resultant velocity. The word resultant simply means the vector addition. So the resultant is whatever it results to, so whatever it ends at. And when we say vector addition, you have to take into account your directions. You have to take into account if you're going, perpendicular, if you're going opposite or same direction. So don't just think this means add them together. So you have to draw it. Upward velocity of 5 meters per second. So 5 meters per second up. And a forward velocity of 7 meters per second. So again, our resultant is from start to finish, which is this side. So a squared plus b squared equals c squared. So we have 5 squared plus 7 squared equals c squared. 5 squared is 25. 7 squared is 49. 25 plus 49 is 74. And then again, we square root. So we get a final answer of 8.602 meters per second. Again, you want to make sure not to overround. So my rule of thumb is 3 non-zero. 1, 2, 3. That's a 0. 1, 2, 3. 3 non-zero numbers. All right, so our last example here. A man rows a boat along a stream from one side to the other. So why don't we draw this out so we can see what's going on. So here's our stream, and it's flowing. And he rows across the stream. So we'll use red for him. He's rowing across the stream at 3 meters per second. The stream is moving at 10 meters per second. So the water is going this way at 10 meters per second. And so the boat, if he is rowing straight across, the boat is going to go slightly downstream as he's rowing. You see your little boat just moving across. So again, Pythagorean theorem. So we get 3 squared plus 10 squared equals c squared. So 9 plus 100 is c squared. So then we take the square root of 109, and we get 10.44 meters per second. So even though he's only rowing 3 meters per second, because the water is also pushing him at 10 meters per second, these two add together as vectors to create this hypotenuse side that is going 10.44 meters per second.